Greetings and welcome to Train Signal. You're watching an understanding of Exchange 2013 architecture and server roles. So before you get too nervous about the word architecture, what exactly do we mean when we say Exchange architecture? Exchange architecture revolves around how Exchange works. Basically, how email flows through and into mailboxes, and the underlying processes that make that happen. So no need to get too nervous just yet when we say architecture. We're really just talking about how Exchange works. So let's walk through this together. Remember, all email and the calendaring items and the contacts and the tasks, all of that information, it has to go somewhere. And eventually you can see it through your Outlook, but ultimately it has to sit somewhere first before your Outlook or your ActiveSync device or whatever it is that you use to connect into your Exchange environment. Before it reaches out and touches that information, it's sitting somewhere. So where is it sitting? Well, it's sitting in a database. And so Exchange needs a database as well as an engine to help manage that database. Exchange uses the Extensible Storage Engine, ESE, also known as JetBlue, as its database engine. And as far as the database, in the end, the database is a single EDB file. And there's one per database. Now you can have more than one database for an Exchange server. You might be wondering why you might do that, but when you look at an EDB file and you see that it continues to grow and grow and grow as email comes into the Exchange server, then you realize that there's value in having more than one database from the perspective of being able to break up your mailboxes and putting them in different databases. That makes it easier to back up and restore those databases in the event you do have some type of disaster that hits, and let's say you need to now restore those databases from a backup. So that's one reason to have multiple databases. Another is from the perspective of performance and having those databases split across multiple drives that you might have in play. The other might be from a perspective of management of mailboxes or management of storage in terms of where you put those databases so that you can make sure you have enough storage space for each of the databases depending on how you're using Exchange. So there are plenty of good reasons to create additional databases. Each of those databases is an EDB file. Now, for years, folks have been wanting a change when it comes to Exchange over to SQL as the database instead of ESE. But in the words of Exchange team expert Ross Smith IV, SQL squeals like a pig where ESE is easy. Now, what did he mean by that? Well, my guess is that he means that ESE still outperforms SQL when it comes to the typical transactions that are performed against an Exchange database. So with Exchange 2013, we haven't seen a switch to SQL as the database and the engine behind it. However, there has been some changes in terms of the architecture with regard to how the database is managed and how things work. Let's talk about some of these. So there are information store processes, Microsoft.exchange.store.service.exe and Microsoft.exchange.store.worker.exe, and these have been completely rewritten in C# to provide greater stability as well as to allow each database to run under its own process. So the value here is that each database now runs in its own dedicated worker process, which means the process of one database will not impact another process on another database in the event that process or database hangs. So that's certainly a benefit in terms of the way Exchange works. Now we call this newly rewritten information store process the managed store, which has fast search integrated into it with better search and indexing capabilities. You'll recall fast search is something that was purchased actually. The company was purchased by Microsoft and pulled into SharePoint with SharePoint 2010. And so now that fast capability when it comes to search and indexing has been pulled into other parts of the Microsoft world, and we appreciate that it's being pulled into the Exchange world. Okay, so we understand that there's a database. We get that. And we understand that there has to be processes working in the background in order to monitor and maintain that database and make sure that it's stable, make sure information can be written to it properly. There has to be a schema involved so that that database knows where to put data. All of that makes sense, right? But how does Exchange literally work in terms of taking an email into the Exchange server and putting it into that database. Let's take a look. When mail comes into the mailbox server, it first goes into memory, and then it gets written to transaction logs. Now these logs are 1 megabyte sized files. So if you have an email that overall is about 10 megabytes, you can see 10 or 11 transaction logs as the result. From the transaction logs, it is then written into the database, the EDB file, when that database is free. So if the database is busy and it's serving a lot of requests at that time, the write from transaction logs to database is held until that database is free to accept new data. Typically, this all happens very quickly. Now, if a failure were to occur, let's say the email has come in, it's gone through memory, it's been written to transaction logs, and let's say these logs have not been written into the database, and the system goes down. How does the system recover? Is that email lost? Well, there's a checkpoint file that helps to ensure all logs are written to the database. So when the server comes back up, the checkpoint file is looked into, and in the event there are any transaction logs that have not been committed to the database, those logs will then update the database, and this helps to keep the database up to date. Now, we're not going to discuss best practice at this time in great detail. However, it's good to note that it's recommended that you separate your transaction logs from your database on separate disks. And the reason for this is so that in the event there is a failure of the disk, you're not losing your database and your transaction logs. It's good to have those separated. At the same time, we'll also discuss in the future some best practice with regard to the performance and safety of your database. Now, all of this is perhaps theoretical to you. Perhaps you've never seen an EDB file or a transaction log. Let's change that. Let's jump over to our Exchange server and let's take a look at the default database that was created when we installed Exchange. And we'll take a look at both the database as well as the transaction logs. We'll see the checkpoint file. And so all of this will become a little bit clearer once you can actually put a face to it, so to speak, once you can see how all of this really works on the server side. Alright, so here we are back on our Windows Server 2012 system, which is running Exchange 2013. If we go back to our Exchange Admin Center and log in, we can see here by looking under Servers and clicking Databases that when we installed Exchange 2013, and this is not something that we did together, this is something that I did before the course itself, and that was just so that we had a functioning version of Exchange that I could use for these early lessons. Not to worry, we'll install Exchange together soon enough. But when I did the installation of Exchange 2013, there was a mailbox database that was created, and it gives it this long, crazy number to start with. And so it's just a way of generating mailbox databases automatically without human intervention. So fair enough, we have this database, it's there. You might want to create additional ones, you might want to change the name of this one. That's fine, that's something we can certainly do all through the tools that are provided by the Exchange Admin Center, and we'll focus on this in a future lesson. But really, what we want to do now is we want to go in and see the database file and the transaction logs. So basically, this is what we're looking at. Here, if you look through Program Files, Microsoft Exchange Server, v15, Mailbox, then you find the Mailbox database. In this case, if we go here, there's only one database, so it's easy to find. There's the long number at the end. And there we have it. Now, we have to scroll down to the bottom to find the database itself, but notice this. It's a single EDB file. It's the largest file in here. And as emails continue to come into your Exchange environment, this file will grow and grow and grow. And so it becomes the largest of files on your whole system, and it just keeps getting bigger. And that's one of the reasons why you need to make sure that you have plenty of space on your storage for your EDB file to grow. And at times you may want to create multiple databases, and so you'll have multiple EDB files. You can put these all on the same storage, or you can separate them out and put them on separate volumes. So as we look at this, you see all of these 1 megabyte files. These are the logs that are building up. Those are transaction logs. And you can see up here the E00, this is the current transaction log, and then all of the logs after that are logs that have been completed and sealed and saved over, so the logs continue to add up, but the current transaction log is always the E00 log. And then we have the checkpoint file here. At the same time, you see there are a variety of reserved logs. This is just to make sure that in the event the storage space does run out, that there is some extra space there. So hopefully this gives you a better idea in terms of how Exchange works, how mail flows from memory into transaction logs into the database. And so from this point, now that you have a good understanding as far as Exchange and the database side, let's jump back over to the slides and let's talk about Exchange server roles and how they've changed from what we had with Exchange 2007 and 2010 to what we have now with Exchange 2013. Okay, so before we go forward into a discussion of server roles with Exchange 2013, I thought it might be best for us to discuss the way server roles have been utilized in the past two legacy versions of Exchange, Exchange 2007 and 2010. Because once you see the 5 roles as they map out here, then you'll understand a little bit better how these roles have been merged down into 2 roles for Exchange 2013. So for starters, we have the mailbox role. That's the easiest one to explain, because even with Exchange 2007 and 2010, this role hosts your user mailboxes with mailbox databases. And the mailbox role also hosts public folders. So that's pretty much unchanged even as we go forward. The mailbox role still does that. Then there's the client access role, which is the connection point for all of your users to their mailboxes, both internally and externally. So the connections require either MAPI connectivity, Outlook Web App, Outlook Anywhere, ActiveSync, or IMAP and POP connectivity. Now the difference with Exchange 2013 you'll find is that one of these is missing. I won't give it away yet, but you'll find that one of these is missing with the new client access role. Then we have the hub transport role, which manages the flow of traffic to and from the mailbox server. Now this was an essential role because it was this role that manages things like transport rules and so forth. So as mail would come in or out of the organization, it would have to hit the hub transport server role. Or if there were multiple hub transport servers, it would hit one of those servers. So all mail went in and out of the organization through a hub transport server role of some sort. And that made it easier for IT admins to establish rules because mail would flow through a hub transport server at some point. The unified messaging role provided a universal inbox for voicemail, email, and incoming faxes. And the way that it did this is it took over for your existing voicemail services and pretty much took over that piece within your infrastructure for voicemail, within your call infrastructure. So you would still have your legacy PBX perhaps connected up to a voice over IP gateway, or you would have an IP PBX, and this would really be the backbone of your call system. But when it came to the point of leaving a voicemail, when a person, let's say, didn't answer their phone and a voicemail would be left, that would be transferred off to the unified messaging server, the voicemail would be left, and then it would go into a universal inbox. And then that message could be put right into a person's inbox. So there were a lot of great benefits to that, but we still didn't see UM deployed on a large scale, not with 2007, a little bit more with 2010, and now with 2013 you'll see that it gets merged in with the 2 roles that we have left. And then last we have the Edge Transport Server role. This provides a perimeter-based server that handles anti-spam and antivirus protection, as well as the ability to establish additional transport rules. Now, the Edge Transport Server role does not get merged into the 2 roles for Exchange 2013. So you might be wondering, well, what happens to the Edge Transport Server role? Well, not to worry, we'll get to that in a moment. But these are the 5 roles that were established with Exchange 2007. Now, the reason why these roles were originally broken up with Exchange 2007 is because processing power was significantly less than it is today. And so when it came to deploying Exchange, it made more sense to break up the various roles of Exchange so that you can put them on multiple servers. However, over time, as processing power increased and as Exchange tightened up a bit and could handle the load a little bit better with each release, with each service pack as it got better and better, starting with Exchange 2010 Service Pack 1, Microsoft started to change its position and recommended building all Exchange 2010 servers as multi-role servers. And so the idea was that you would install a server with multiple roles, typically the mailbox server role, the client access role, and the hub transport role. The unified messaging server role would only be included on servers that really required that if you had a UM infrastructure in place. If you weren't using unified messaging, then you didn't have to install that piece in your Exchange environment. So the idea was to have multi-role servers because it just made sense to install all the roles on one box. Let's look at the way this would all play out in an organization. So in deploying Exchange 2007 or 2010, what you would do is on the internal network, you would deploy multiple roles either on one box or on multiple boxes, and these could run in a physical environment. You can run these server roles on the physical systems themselves, or you can virtualize all 4 of these server roles. Now that was not always the case. Microsoft did not always support virtualization of all of the server roles. For example, the unified messaging server role was not supported until Exchange 2010 with Service Pack 1 or 2, and so that role would not be able to be virtualized. But ultimately you would deploy these server roles either together, all 4 of them on one system, or separated out, and you would do that on the internal network, which means the server that you would deploy them on would be a member server connected up into your Active Directory domain. Now, on the perimeter network, also known as the DMZ, that's where you would place your Edge Transport server. And that server would be utilized for additional protection, antivirus, anti-spam, as well as additional transport rules. You might also deploy in the perimeter additional servers or services that would help to protect your internal network. Perhaps you utilize something like Forefront Threat Management Gateway or something up in the cloud or some other solution in play. So there were a lot of different options that you could utilize to ensure that you protected your internal network. But all of those things would run either in the perimeter, which would be separate, so the Edge Transport server is not a member of your Active Directory domain, or it would be a service or solution that ran in the cloud. So that's the way things work in Exchange 2007 and Exchange 2010. How have things changed with Exchange 2013? The server roles for Exchange 2013 actually mimic the same roles that we had with Exchange 2003. Granted, the technology has changed greatly, the code has changed tremendously, the actual functionality of Exchange Server has changed, and the way we manage it, so many things have changed. But with Exchange 2003, we pretty much had a front-end server that handled client access coming in, and we had a mailbox server, which is the back-end server for handling databases and mailboxes. So with Exchange 2003, we see a return to basics. We have the mailbox server role, formerly known as the back-end server, and the client access role, formerly known as the front-end server. Now, even though we're using these terms, front-end and back-end, really we're still looking at it from the perspective of the modern set of server roles. How do the modern roles play out when it comes to merging them into these 2 roles that we see here? Well, let's first look a little bit deeper at the client access role and see what the client access role is designed to do in Exchange 2013. So for starters, the client access in 2013 proxies connections to the mailbox server. Now those connections might be from Microsoft Office Outlook, Outlook Web App, which is the browser-based flavor of Outlook, mobile devices that have ActiveSync connectivity. So if you have an iPhone or an iPad or an Android device or a Windows phone, all of those mobile devices have ActiveSync connectivity. POP or IMAP connectivity and SMTP connectivity, depending on the type of the email application that you're using. So all of these connections go through the client access server in order to connect to the mailbox server. So that's what the CAS role does. It enables clients to connect to Exchange. It performs authentication, redirection, and proxying while the mailbox role processes the request once the mailbox role gets that request. And the CAS server has 2 services, which we'll discuss in a moment. It has the client access service and the front-end transport service. So that client access service provides the authentication and the redirection, and it works as a proxy to that mailbox server. But the front end transport service offers the protocol, connection, recipient, and sender filtering, and it also helps to determine which server is the proper active mailbox server for the request that's coming in. Now, one benefit to this change is that Layer 4 load balancers can be used to balance the traffic between CAS servers grouped together in an array. Now, why is that important to note? Well, if you're establishing larger organizations, if we did it with Exchange 2010 or 2007, we would have to make sure that our load balancer allowed for Layer 7 load balancing, and so this was a little bit more expensive. And so now we can work with lower level, cheaper, we should say, devices that can load balance that traffic. So that's just an added benefit to the change up in the architecture, going to the client access server handling all of that traffic in that way. So that's just one of the benefits to adjusting the architecture to a 2-server role environment with the client access server handling connections in this way. Now, we mentioned that there are 2 services, the client access service and the front end transport service. So if we look at the client access service, this provides the unified namespace, the authentication, and the security. It routes requests to the right mailbox server. It proxies or redirects requests for legacy servers as well. So when you're in the middle of a migration and you might have additional servers in the mix, let's say you have Exchange 2007 or Exchange 2010 mailbox servers that you still have in your environment, the client access service is what helps the client access server to redirect that request toward legacy servers. At the same time, we have the front end transport service, which provides, as we said a moment ago, protocol filtering, network protection, and it also locates the mailbox. So the value of that service is that it allows for less hops, unnecessary hops, because it determines the best mailbox server to deliver the message to. So that gives you just a basic idea of what a client access server can do, what these 2 services can do. There's obviously more that you can learn if you want to dive deeper in the architecture and in the services of the client access server. But for now, we'll move forward. Let's talk about the mailbox server and the services that are provided through the mailbox server role. So the Exchange 2013 mailbox server handles the following. Mailboxes, including the ability to have database availability groups for high availability. So that hasn't changed when it comes to the mailbox server. But it also handles unified messaging services. So that role, which was its own separate role under Exchange 2007 and 2010, well, now it's completely wrapped up into the new mailbox server. And you'll see in a moment, when you do an installation, you don't have to choose the unified messaging server role. If you install a mailbox server, the unified messaging server services are bundled in already. There's no choice, it automatically gets installed with the mailbox server. In addition, the mailbox server handles Outlook Web App, ActiveSync, and Outlook Anywhere, or RPC over HTTP sessions. Now, you'll note we mentioned that the client access server makes the connection for those clients, so those clients come through and eventually they get passed to the proper mailbox server where an individual's mailbox resides, and then those sessions can exist between the client and the server itself. Then there are mail transport service elements that were previously handled by the hub transport role that now are handled by the mailbox server. So some of those elements were split so that the client access server handles some of them and the mailbox server handles the other pieces of it. So the mailbox server itself handles the hub transport service that's used for mail routing within the organization. And what it does is it provides connectivity between the hub transport service and the front-end transport service, which is handled by the client access server. Now, if you recall the various server roles that we had with Exchange 2007 and 2010, you might be wondering where the Edge Transport Server went. The Edge Transport Server still exists, and it can be deployed as Exchange 2010 SP2 Edge Transport. That's currently. So if you still want to have an Edge Transport Server for your organization, that's not a problem. You can deploy the Exchange 2010 SP2 Edge Transport Service. An update is supposedly due out with Service Pack 1 for Exchange 2013. And so we'll see an update to the Edge Transport Service. Perhaps they'll call it Edge Transport 2013. Now, just to show you one thing, we haven't worked through an installation yet, so you haven't seen the options for an installation, but I wanted to show you this screen. We typically like to show you an actual demonstration of an install for you to see all of the different screens. The only reason we're showing you this one at this point is so that you can understand that those two server roles are the only roles you can install on a server. So when you go to do an installation of Exchange 2013, you can install the mailbox server role, you can install the client access server role, or you can install both. So those are your only options. Whereas with previous versions of Exchange, Exchange 2007 and Exchange 2010, you could pick and choose the server roles you were looking to install. The only thing you couldn't do is if you chose to install an Edge Transport server role, you could not install any other role with that server. And the reason for that is pretty obvious, and that's because, as we mentioned, the Edge Transport server is in the perimeter. It's not on your internal network. It doesn't connect up to Active Directory in the same way, so we're not able to install additional roles on that server. That's a standalone role, whereas the other roles could combine. So the same is true here when it comes to mailbox and client access server roles. We can install them separately, or we can install them together. So now if we look at just the change between the architecture that we had before and the number of server roles, you can see that we have much less that we have to work with. If we are on the internal network, we have one server perhaps that's running the client access server and mailbox server roles. We can merge those two together and install them together. Or we might have multiple servers. They could be physical or virtual servers. Virtualization is supported for both of these server roles, so that's not a problem. And so we can have the mailbox server role as a separate server or servers, and the client access server role as a separate server or servers. And so if we do have multiple client access servers, and let's say we want to merge them together in an array, we can do that. We can have them all act and function together, load balance those services. We can use a load balancer, a hardware-based load balancer, to load balance those services. And then back on the mailbox server end, we don't necessarily need to load balance because the mailboxes are not spread across multiple servers. But what we can do is we can make our mailbox servers more highly available by creating database availability groups. And so that allows us to have redundancy of that data. We can establish from our active copy of the database, we can create passive copies of that database. All of that's a bit much to get into at this point. We will go into it a little bit more in future lessons, however. But you can see that there's been a dramatic change to the architecture. And then out on the DMZ, the Exchange server that's there is the Exchange 2010 SP2 Edge Transport server. So again, that's still a possibility to utilize Edge Transport services. It simply cannot be done with Exchange 2013. They did not give us an update to the Edge Transport service. The last thing we want to talk about before we conclude this lesson is client connectivity. Outlook connections in-house have always been MAPI connections. Not anymore. Direct MAPI connections are no longer supported with Exchange 2013. So RPC connectivity with MAPI, that's dead. RPC over HTTPS is now the connection method for Outlook connectivity. So you might be thinking, well, wait a minute, isn't that Outlook Anywhere? Yes, that's Outlook Anywhere. That is the new connectivity method. So this is a big change in terms of the architecture. MAPI's gone, RPC is gone, and now we use RPC over HTTPS. Now, RPC over HTTPS or Outlook Anywhere, this has been supported since Exchange 2003. But you might think about this and say, yes, I've worked with this, and it has been supported, but the only purpose was to allow for an Outlook client that was outside of the organization to connect directly into Exchange without having to go through a VPN. Well, that's all well and good. And so your MAPI clients, your Outlook clients, what they would do is they would wrap or encapsulate traffic inside of HTTPS packets, and then it would connect in without going through a VPN. Well, the good news is that now you can do this internally or externally, and you won't have to worry about MAPI connectivity. So the client access server has one less protocol to deal with now. So what happens is once the client is authenticated by the client access server, it uses a user's unique GUID to query Active Directory, and the primary Active Manager will determine the active mailbox server, and then it will redirect the Outlook request accordingly. So that Outlook client will no longer connect to the client access server using RPC. It will always connect using RPC over HTTPS or Outlook Anywhere. So I know if you're new to Exchange, you might be thinking, this is not a big deal. Okay, fine. I don't know what all of this is just yet, but fine. It's RPC over HTTPS. It's Outlook Anywhere. Gotcha. Let's move forward. But for those who have worked with legacy versions of Exchange, and this is perhaps the first time you're hearing this is actually a big change to the architecture and a very important change in architecture for Outlook clients. Okay, so now that we have a good understanding as to the architecture, how Exchange works with regard to the databases, with regard to how mail flows into the organization, with regard to the server roles and how there are only 2 server roles in Exchange 2013, although you can say there's a 3rd server role if you use the Edge Transport server, but it's not a 2013 server role. Remember, it's a 2010 server role. But now that we have a good understanding of all of this, it's time for us to move forward and look at the prerequisites to installing Exchange and then do an installation and start moving forward with using Exchange and getting an Exchange environment up and running. However, all of this information is incredibly valuable because an Exchange administrator is not just someone who knows how to click a few buttons. It's not just a person who can click next, next, finish, and do an installation. No, but you have to understand how all of this really works. You need that underlying foundation to your knowledge before you go forward and start actually making things happen as an Exchange administrator. So we hope you found this informative, and thanks for watching.